Okay.
Okay.
Okay, insight into program means if you when you write a program, what is going through inside the computer. So that's what we gonna learn today. Everyone know that the programmers write high level languages, and the high level languages have certain rules. So if you write a C code, you have to start with header, something called header file, include hash, include a standard input output dot header. You have to start with this sentence, and then you write declare any variable, or if we calculate any arithmetic calculation or any logical calculation, there is a certain format for particular language. So in Python you don't need to write anything, directly you can assign a variable and then calculate a plus b or whatever. So then after writing a code, there will be a execution process. 1 second, who's that? Amita. So that execution process will happen only inside. So whatever the program we write, that is high level languages, it converts into machine code. So that binary code, right? So machine only can understand that binary code. So who will translate that high level languages into machine level languages, and then what software makes executing all those things? You're gonna read that. You're gonna study that. That is called insight into program execution. Okay, the basic normal scenario. The programmer writes high level languages with certain rules. For example, Python. Today I am going to show you that editor, which is called PyCharm. See, can you see that? This is main.py PyCharm. So on the right hand tops, this is called editor. Whatever program I'm gonna write, I'm gonna write it here only in this one, which is called main.py. Okay. Then on the bottom, that is console panel. Whenever I run this code, all the errors or output will be displayed here. Here left side panel, module, whatever the program I write here, in the right side, this is called PyCharm editor. Okay, so the right side, this is the editor, where I write a program, Python program. So here left side, can you see there is a file called the abc.dat, then binary.dat, and then main.py, extension is py, which is a Python code. When I save that, it will save as a module here. These are all, each program, the .py is called a module. Okay, let's come to here. Okay, after we writing a Python, not only Python, any programming languages, it converts into machine understanding code. So what is a machine understanding code? We know that it converts into binary code. Before that, there is a one phase, I will explain later, assembly language. So when computer started, that time people, how they are writing, they don't. Now PyCharm easily, you don't need to declare any header file, you don't need to assign particular variable. Just a equal to 15, you can assign that. And then if b equal to, you can assign 10, and then you can calculate c equal to a plus b. A plus b, then you can directly, you want to show the result, you can use a print command, then print the result. Print which one you want to print. You want to print the result. So the result is stored into the object called C. So I can use it here. There is a green triangle button on the editor. See, let me see the cursor where moves. So this, when you press this button, or you can run from here, run main, or shift F10. So in your computer, there is a button called shift and then F10 key. So if you press it, this code will be executed. So let me run this. What you will get, 10 plus 15, you get 25. So nicely, you don't need to worry about how much memory allocation, what is the length of A, what is the length of B. You don't need to worry about anything. The Python will allocate the memory. But earlier days, they write code in a assembly format only. So how they write add, assign A, then assign B or something, then add A comma B. That's how they write a code. So which means the compiler, so the computer reads this way. So assign A. So which means that the variable A is allocated for some memory. So if it is an integer, it will allocate some 16-bit or 8-bit. Each and every line of code they will write as a return format. So this kind of code is called assembly language. So after converting programming language into assembly language, then it will transfer into binary format. Nowadays, in the modern computer, they don't need to read all those assembly language or whatever. You can simply say that high level language into machine level language. Okay, first of all, let's see basic flow of compilation. So what is that meaning of that? So what, how when you write a program, high level language program, so whatever you write in a program, that is called a source code, right? You have learned that source code. So into object code. So what is the object code? So nothing but a machine code, right? Okay, first we write a source code. You see in a Python, whatever I have written, when you save this, this is called a source code. So that source code is translate into binary form. So that there will be a translator in between. So we earlier days they use only assembly language. So convert all the programs into assembly language and then into binary language. And nowadays it's changed. Only either compiler or interpreter converts that binary form. Okay, so let's see how the compiler and the interpreter works and how the execution happens. Okay, so my first thing, let's compiler. Let's see the compiler. You see, compiler is everything is a software program, right? So compiler is not like any chip or any machine or any you see that memory card or whatever. No, nothing. Everything is a program here. So in the compiler, what is the main job? It converts. Sorry, before that I will explain one thing. Compiler and the interpreter, their motto is same. They converts high level languages into machine level language, but the way of processing is completely different. Okay, so the compiler converts program everything together and then convert into machine level language, but interpreter, it converts line by line. If anything happens, then it will stop and then it will throw error, something like that. So the compiler also, it converts every program into converts, and then it will binary code, and then it will throw the error with the error message. Okay, let me run here. First thing, okay, before that I will explain one more thing. So that is a main different. The compiler converts the code, entire program at a time, and then it will throw, if there is a error, it will throw error, right? So, but interpreter takes a single line of code and then it takes an input and then whatever it assign some other algorithm. Okay, for example, if okay, C++ or using a compiler programs. So the Python use interpreter conversion. Okay, so the compiler, as I told you a number of times, converts the entire program and then it will wait for another execution, another process. Process means nothing but it is a job. for example, in this computer, I'm opening some Windows Explorer, some other Internet Explorer. Here, I open 3 tabs. You see WhatsApp, web, and then W3 School, and then meeting, some other Google.com, whatever. So then if I click here PyCharm, then how memory allots, which one runs first, and then so that there is a priority, right? You have to organize everything. So if I ask you to run a program, then simultaneously if I ask some other thing, okay, take your PDF file. So then what you do, you give some priority, right? So you are doing some coding here, then when I come to you, come and then ask you, okay, where is that file, just send me that file. Then what you will do, okay, you will start this Python program, and then you will find out your file where it is saved. Then you will obviously you will open that in Windows Explorer, and then you will check where that file stored, and then take that file, and then any via through email or through WhatsApp, you will send me that, right? So you will give a priority for any job, right? The same way, if you run many things in a computer, nowadays it is a multitasking, right? So the earlier days, only if I open a computer, then I can only work with a particular application or whatever. When I studied that time, Fortran programming language was there, and then COBOL programming. When I open a computer, I can only work with COBOL either or Fortran or whatever. So nowadays operating system changed. Many things you can work at a time. So multitasking. So we have to learn how the compilation, the compiler has to know which one runs first, and the same way in the program you will run many functions here. So function means you will study later. So here, if you are going to write 100 lines of code or 200 lines of code, so you will execute many functions. So the function means it is set of piece of code. See, for example, if I declare here, define add some function. So I'm closing some function here, close, add, or whatever you can add, which means whenever I call add, this function will be executed. See, the whatever inside that function, a, b, and then we are assigning to variables, and then in some calculation, a plus b, or a into b, whatever calculation is done, then we are printing that. So this is called a complete function. So in my program, I can use n number of functions. So when I run this code, so it will allocate memory. Okay, define add function has the 2-3 lines of code, which means only 2 variables are allotted. So one runtime variable is there. So memory CPU will allot these kind of things. So this is what we gonna learn here. Okay, so the compiler has a certain stage, how to work, and then what kind of process is going on. So many books, different textbook will show you 4 stages, 6 stages. Oh, it's nothing to worry about it. First one is processing, then second stage is compilation. So compilation has some sub categories, that is front end and then back end. So then next one is assembly, linking, and then loading. That's all. You are going to learn about these kind of things. So okay, well, first what is compiler, how it works, right? So the okay, the compilation, first step, processing. So what is a processing? The first stage of compilation is called processing. So what it will do, in this phase, it removes all the commands. Okay, what is a command? Here, let me take out this function. Whenever you start writing a program, you can use some commands. So command is nothing but with the triple quote, you are writing something. This program is for calculate addition. You are using some other information about yourself. Whenever you use some command, you will easily understand. Suppose if you are writing a 500 lines of code, what is this function doing. If you scroll down a little bit, you don't know, you have to dig out line by line, then only you can understand any programmer. For example, Shweta Lakshmi written 100 lines of code and then asking to other person to compile and then run and then add some other module. Then the second person, how they read that program, they don't want to read line by line, right? So by practicing what they do, they write some other information. Okay, this program is for calculating addition or whatever. Then here you can use hash sign to write something. Adding to variable. So you can add it. So whenever the programmer scroll down, okay, this is what happening here. This is addition. For understanding purpose, we do something. So but when you run this program, the compiler won't take this command. This is called the command statement. This, after hash whatever you write, the compiler won't take this part. So it excludes this command statement, and then only it collect that information, whatever the data you pass, whatever the condition, whatever logical operator, all the statement, it collects that, and then it group into separate code. Okay, so separate assembly language. So this is called command statement. Okay, the processing phase, the first phase, let me take that note. Okay, so in that processing state, it removes all the command from the source code. So you know that this is entire thing is called a source code. The compiler removes this command lines, whatever the command you are assigned here, it removes it, and then it add the required components. So what is that required components? For example, in my program, so simply adding a plus b, nothing, you don't need to add anything. If you write a big programs, the power of 2 or square root or some other calculations. For example, if you calculate math dot seal, what it will do, it will round this number upwards. Upwards means, if I ask you to round this number, you will say 2 only, right? After decimal point, whatever 5 and above, then only you will round that number as a 3, right? But here this math function, math dot seal, it will round. For example, I am passing this value 2.3. If I use this math dot seal, what I will get? I will get a 3. It round that number upwards. So seal means a ceiling. Ceiling means on your top. You can see that, right? So that way it will round. So before that, I have to import some other module. Import module, math module. So if I use this function dot seal, I have to import math one. Okay, so in this way you're gonna write a program. So before here in the compilation process, first it will check, okay, what are all the modules I have to import. In this statement, C equal to A plus B. So this is basic arithmetic operation. You don't need to import anything. But compiler has to understand, okay, here some calculation is going on. So I have to fetch that mathematical module, normal built-in function. Some basic calculations are, calculated by itself. This is called built-in function. when you install that calculations part, that arithmetical or logical calculation, everything will be included. So that by default it is included, that is called built-in function. Okay, so the compiler, it will check whatever the module I have to, compiler calculate and then arrange everything. First thing, it removes the dot statement, command statement. Then it will assign whatever the requirements, any modules we need to import everything. It will write in a assembly code. Then once everything is assigned, then it will go to the next phase. Until this, you guys okay, or am I talking blindly, guys?
Okay. Okay, ma'am. Okay, ma'am.
You all understand, right, what I said? This is theoretical part. You will get sometimes you don't understand, guys. After talking, please mute, otherwise it is echoing on my
Ma'am, it's hanging, ma'am.
Guys, can you hear me now?
Yes, ma'am.
Yes, ma'am.
Okay, okay. I don't know what happened. Where I stopped. Anyone can tell me that where got disconnected? Guys, you there?
Yes, ma'am.
Okay. Can you tell me where I stopped? Which part? Okay, let me explain one more time. The processing phase. Okay. So I don't know where I stopped, where I got disconnected. I'm not sure. Let me go through one more time. Pre-processing. See, sorry, I said processing, right? Pre-processing. So pre-processing means when after finishing your code, if I say Python code, don't stick with Python code. Any programming languages, either COBOL or C or C++, or you're writing a database code, SQL, whatever the code, this compiler, compilation, and then interpreter process is same. Okay. So here compiler and then interpreter or the translators, it translates the high level languages into machine level language. So their job is same, but the way of execution is completely different. Okay, pre-processing means first it will remove all the commands from the program. So commands, why we are using commands to understand that code. After 100 lines of code, you don't know what you have written. You don't want to keenly read line by line, right? So when you go for job, you always work with a team. No, only not only single person write the entire code, right? One person write this module and then another person write for example, if you calculating purchasing something, then it will upload in the website, so any from worldwide the people, they will access, right? So the dollar conversion will be there. Each and every country has different currency. So everything, the conversion model, the second programmer will work on conversion model, and then third programmer will work on different, the HTML format, what many things will come together. It will consider as a program, right? So that time, imagine I'm writing 500 lines of code, and then I'm asking some programmer to next programmer to merge with their code. So how they merge, there is a function, they have to check. They don't want to check line by line. So for understanding purpose, we write here, command statement. Whenever you scroll down, okay, you can find, okay, this function is calculating for quadratic equation, or this function is calculating for anything, converting centigrade to, Fahrenheit, whatever. So that purpose only, we are writing this command statement. So how you write? Using triple single quote, or in the triple single quote, when it starts, when it finishes, in between whatever you write, either 2 lines or 3 lines, it will work. But hash sign, it will after hash sign, only one line you can write it. After that, when you press enter, the compiler will take that sixth line. See here, there is a line number. Compiler will take that sixth line as a program code. Okay, so it removes the pre-processing stage. It removes the command line, and then it will assign whatever the modules is needed, whatever memory allocation is needed. It will calculate some other flowchart or diagram. We will see later how it will arrange. The compiler do that process. So that is the first stage. So after assigning that module, imported module, or removing that commands, everything, then it will goes to compilation phase. The compilation phase, this phase is divided into 2 parts. So first one is analysis phase, then second one is synthesis phase. First one is called front end, and then second one is called back end. Front end means immediately you can see, let's see whatever the program we are writing, this is a front end. Back end means a data. So imagine here you assign one variable, so that is a 15. When you close that program, this data will be, it won't store in our computer, right? So for example, I'm using input variable. So input means when you run that code, okay, only one thing I can input enter value. When I run this, it will ask me to enter value. So first time I use 20, then it will assign A equal to 20, then B equal to 10. When compiler moves to third line, it will calculate 20 plus 10 equal to 30. I will get the resultant value will be printed 30. Okay, so I have to enter, press enter. There is a, okay. Okay, there is a procedure. I have to make it different way. I will write it down. Okay, see, whenever I write this kind of statement, the compiler should wait for that value, right? So see, when I run here, it is waiting. Okay, I have to enter that value, right? This is the front end phase. So back end phase means, when you go for any grocery shop, any clothing shop, what they do, you purchase any two chocolates. If you in a grocery shop, if you purchase chocolate, they just take that billing page. They will write. They will code. There will be a code, right? In the Kinder Joy, and there will be a code 2 1. They have assigned some other code. So that code will fetch that chocolate name and then price of that name. So we don't, the cashier won't write type manually. Okay, Kinder Joy or 5-star. They don't do it, right? Just they'll assign that code name for that particular product. It will take that value. So where the chocolate name and then price will be stored, it is stored in the database, right? So database is you can say that backend. So another way you can say backend means how the compiler translate a code into machine code, then how memories are allocated for each and every process. That is also called backend. Okay. So in two ways you can say that backend software, you can say SQL database, whatever the data stored inside, that is backend software. If you say backend means how the operating system, how the compiler, interpreter, assembler works, to study about those things, that is called backend study. Okay. So let's move on to analysis phase. So the analysis phase, compiler identifies all the individual units, which is a keywords or variables. Okay, let's move on to PyCharm. Here, okay, let me take out this. I will assign 25. Then B equal to 10. So when I start run this program, so what the compiler do? Okay, it needs to allocate memory, right? So here, when the compiler goes to first line, line number 3, okay, it will allocate that this variable A. This is called variable, right? So variable A has the 2-digit code. So do 2-digit data. So 2-digit data means it will allocate a 2-bit of memory. So in Python, you don't need to specify A should be 5-digit or whatever. Before in earlier program, olden days, whatever we learned, we have to declare A is an integer. Imagine if I study C program, if you write a C program, A should be integer, and then B should be it is a string type. So if I assign integer, it will come, and the memory CPU allocates memory 8-digit or 16-digit. how many digit for an integer. The default memory allocation will be there. Okay, integer means 5 digit or 8 digit. I'm not sure particularly how it allocates, but Python you don't need to worry about anything. If you pass 2 digit number, it will allocate 2 bit memory. Okay, so it will allocate, it consider how many variables are there. What is a keyword? So print is a keyword. If then many condition statements are there, right? If, while, loop, and then true or false, these are called keywords. You cannot change anything. You cannot, it is a case sensitive. You cannot even write print of, you cannot write like that, so it will throw error. Okay, so these are all called keywords. So the analysis phase, it will assign that memory. Okay, and the variable name you can give anything. So you can give student name or student roll number. You can assign anything variable name. So what a compiler do, it will check first line. Okay, here there is a variable. In Python everything is called as a object. So this object has only 2 digits. Okay, immediately the control unit, CPU allocates a memory for this variable. Then it will come to second line. Okay, this is a variable object called b. It has only this many bit of data. It will allocate some other memory. When the program runs, so the compiler goes to third line and the fifth line. Okay, it will allocates a temporary memory C equal to whatever the addition or subtraction. A running time, it allocates memory. You need memory to run anything, right? Any process. So that is what the CPU, the responsibility allocates memory for this and that. Okay, when compiler comes here, there is a arithmetic logical operation. Immediately the control unit takes place. Okay, arithmetic logical unit to perform this do work. And then for example, in my program I use condition. If a is less than b, if it is true, then do something. If it is false, you do something. I am assigning some other thing. So that means the control unit has two different, right? So arithmetic and logical unit. Each every unit takes their responsibility. They do that. Who controls that? Control unit control that, and then CPU allocates memory for everything. So, come on, guys, you okay with that? Anyone
Yes,
can?
ma'am.
Okay, this is how it works. Okay, let's move on to analysis phase. So the compiler identify all the individual units. What are all the keywords? What are all the variables? It will identify, and then requirements. If need arithmetic operation performs, it will create a table. That table is called a symbol table. Okay, so you have to mention that symbol table. Talking is good. First the compiler analyzing phase identify how many variables, how many keywords are there. It will create a table. You don't see it, as you don't, no one can see that kind of table. It will create that table. That table is called a symbol table. It determines the why it creates a table. It determines the memory location. Okay, the variable a needs 2 bit of memory here. Variable sorry, scroll number, yes, roll number needs only 2 bit of memory. So variable b, second variable needs this much memory. So that purpose the compiler creates that symbol table for arranging that memory allocation. That is called front end phase. And then move on to back end phase. So back end phase means the compiler generates syntax tree. Okay, what is the syntax of the source code? What it will do, for example, okay, I'm assigning that this is the string variable. Imagine for easy purpose I'm using variable called a equal to John. If you in Python, if you're using a string, a character variable, you have to declare with a double quotes. Okay, so by accidentally I missed that one quote here, or if, by mistakenly I have written single quote here, so it will throw syntax error. So the backend, it will check, first thing it will check that variable, the analysis phase it will check that, see the analysis phase, it will check that variable, how many variables are there, how many memory units we have to allocate. It will create a symbol table. Second thing, symbol, the synthesis phase, what it will do, it will check the syntax error and the semantic thing, semantic rule. So okay, syntax error means when I run this code, it will show that this variable declaration is not correct. See, syntax error while scanning the string literal. So which means I have to change something. So when I start with a double quote, I have to end with a double quote. So if in Python, if you working with a character data, if you assign character data, you have to declare with a double quote. You cannot write John like that. Okay, it will throw me throw error, some error. So this is called syntax error or name error, whatever. Okay, so the second phase, it will find out whatever the errors, the compiler check line by line. It will throw that error message with line number. See, can you see here file? So the file where it is stored, it will give that full path, and then line number 3 there is a error. Let's imagine syntax error. Let me run here. See, it will show in line 3 there is a syntax error. Okay, then this semantic error. So you know the meaning of semantic, right? Anyone knows what is the meaning of semantic? Semantic rule. What is that? Anyone? This is a general English word, a semantic rule. What is that? You guys are talking nicely. Then, if I ask first, then anyone can tell me what is the semantic rule. I'm the one talking all the time. Just speak up. Anyone speak up? Ramita, can you tell me what is a semantic rule? Guys, can you hear me now? I don't know, some network issue. Yeah, I keep on disconnecting. Okay, have you seen this message? I type anyone speak up and then am I audible? Anyone seen this or not?
Ma'am, you didn't share your screen, ma'am.
Oh, really? Okay, okay. Completely disconnected. Okay, no problem. Okay, what is the meaning of semantic rule? That is a general word I'm asking. Semantic rule. Syntax meaning if you are declaring something in a program, so that will be a format. You have to declare this function to be like that. So say, and for example, if you are assigning my string variable, so in Python, you have to declare within double quotes or single quote, you have to assign. So that is a syntax. So what is a semantic rule? In general term, anyone have an idea what is a semantic rule? Anyone? What is a
No,
semantic
ma'am.
meaning? No? Okay, semantic meaning is nothing
No.
but it is a study of the language. For example, if I use if statement, if apply if okay, let me write it here. If A is greater than or less than B, come on, A is greater than B, then I'm asking to print something. Print whatever A. If
Your
this
screen is
condition
not
is
shared.
false,
Your screen is not shared, ma'am.
oh really? Oh my gosh, oh my god. Oh, okay. Now you
Yes,
are
ma'am.
present. Okay then. Okay, semantic rule means is if you are in here when you apply that logic, if A is less than B, print A, else print B. Okay, you are using some condition, so this condition should be meaningful. Okay, so you that kind of thing is called a semantic rule. So if if you in Python you have to declare with a colon, this that is not a way semantic. If you use A less than B, you have to either use else statement or you simply print A and B. You can do that. So you cannot write while A or something. So irrelevant conditions or any programming step, that is called a semantic rule. So in Python you have to inside you are creating some condition. Yeah, you have to finish that condition. Inside that condition, if, for example, if condition, you can use many loops, but that inside that loop should be completed. So you cannot leave if A is B, then do while loop, that's it, exit. You cannot do that. So that kind of rule is called a semantic. So here what the compiler in this synthesis phase, it will check every rules are followed properly, and then syntax are whatever the declaration and the syntax are error free. Then only the compiler check those things in a second phase, and then it will move on to third phase. Okay, I'm tired now, already time's over, right? Okay, few more minutes. Okay, let's move on. So then after that it will goes to assembly phase. Okay, so you know that analysis phase and then synthesis phase, right? So analysis phase, the compiler will create a symbol table. So what is a symbol table? It will identify variables and then keywords. So what are all the availables in the source code? Using that source code, it will create a symbol table. Why it is creating a symbol table? To allocate the memory. Okay, so that is the main purpose of symbol table. Then let's move on to assembly phase. Assembly phase, it receives the assembly level instruction and then convert into object code. So see that is what I told you. If you write if you read a COBOL code or anything, so the assembly level code will be there. Add A comma B, and then base exception. No, I don't want that. Even though in Python program you can write some of the assembly calculations. So let's assembly phase, it will check either any assembly code is there or not. Then if it is not okay, if in our code we just written in a high level language, it will consider treat as convert into assembly code, then check all those things, then only it will move on to object code. So which is object code means machine code, so that is 0 and 1s. Okay, so this is the main thing of assembly code. Then linking. So after these phases, what are the phases? Compilation phase, pre-processing, and then assembly phases. So the libraries are linked. Okay, so here first what it will do, it will delete that command statement, and then it will assign that import any modules are there. So then second stage, it will check that variable. So for memory allocation, it will check variable or keywords, whatever. Then it will check the background checkup also. Background means the syntax, and then other rules are followed properly. Then it will move on to assembly phase. Assembly phase, any assembly code is there, then it will take it. Otherwise, it will convert into assembly language and machine readable language, then into binary language. So linking stage, after error free, then it will link into some other libraries. So I said in C program, in Python program, you will read many library modules, which is called, the math.cel, ceiling math.floor. So if you use this function, you can attach that library, that library called math library. Okay, so that is a default built-in function. Explicitly we can use some other libraries, URL. Later you will study what is library, and then what are all the functions are there. So web browser, this is our URL, web browser, these are all called libraries. So the compiler will fix what kind of libraries you want to link with particular this program. So these kind of process will be there, right? Then after that, the compiler process is over, then operating system will take care of next thing. Okay, after linking thing, when it links with the library, that is called linker. And then with the help of operating system, all memory references and the resolved and the code is converted into the form of requires execution format. See, what is that in the form of execution format? Okay, first what compiler do, it will check any command statement and any syntax error, everything. Then when you run that code, in everything is over, no compiler, no error, nothing. Then only it will goes to convert into machine level language thing. So here, before that, some linker will link with that libraries. What are all the libraries available in Python? You will study later. Okay. Now, okay. When you save that file, this is called program, right? This source code extension of exe. So forget about this. If you are installing something from the website, for example, PyCharm. You're gonna install PyCharm on your laptop or desktop. What you do, well, you go to website and then take a PyCharm, install PyCharm. Then when you click here, there will be an option download free PyCharm or whatever, right? So after clicking that in download, that there will be a exe file. You have to run that exe file, right? So same thing that will apply here. When all the compilation process done, it will be converted into executable file. So that is extension is .exe file. Okay. Until this, you all okay? I'm talking too much. Maybe you get confused, I don't know. Guys, just give me feedback until this. You know what it does, how it works. Then we will wind up now and then we'll see tomorrow. Okay, linker and then loader. That's it. Then we will move on to interpretation process and then operating resource management next class. You got it right, Tanisha?
Yes, ma'am.
Vyabinya. Okay then. Okay. So only here too in this chapter we will study only understanding the translation process. I mean compilation process and then operating system resource management. We are not going to study that cloud computing because it is not included in your syllabus. Okay. So theoretical part I may ask many times questions. So just go through this. Today's test, I'm not included this only up to logical circuit, to 10 MCQs and then few descriptive. I'm gonna ask to draw the logical circuit. Okay, you're gonna write maximum 30 marks. I think so. Okay, guys, all the best because principals are asked to every day you have to write a test. So I'm conducting only not new chapters. We did not have enough time to cover new chapters, right? Okay, guys, I'll wind up now. See you tomorrow. Okay, 4 o'clock, 5 o'clock, right? 5 o'clock, I will post a question paper in the Google Meet. Bye now.
Thank you, ma'am.
Thank you, ma'am.